Okay, so for this lab, to start, going over the PowerShell script, it regularly checks CPU, so memory, disk usage, CPU, and then performs the remediation steps. So killing high CPU processes after identifying them, clearing the memory cache, clearing temporary files, and outputting those results to a log file. So I used functions because with that, like with any other scripting language, using functions eliminates redundancy and allows us to quickly reuse the same code. So for the first function, what this one does is it's to log the information to a log file. So the parameters would be the message we want to send to the output to the log file, and then it'd be the path to the log file. So it will be used later on. So every time we want to write to log, it'd be better to have a function that we can just uh, call it, and then whatever message you want to write to the log, and then it will output to the file. So, like for example, here when the CPU it finds the total CPU usage, it'll just just call the write log function that I declared earlier, and then it would output to the log file here, the variable for the log file. What this is a get date commandlet for formatting the date. So each time in the log file there's an action happens, they'll write the date of when that action occurred, and then we pass this to the timestamp variable, and then we use the add content commandlet with the path of the log file, and then it will send the timestamp and the message to the log file. And then this one is for the remediation action. So whenever the CPU usage is high, it'll kill the high CPU usage, and then it will log to log file what was done, what message we want, the path obviously, and then the same step with the timestamp, and then adding it to the log, redirecting to the log file. And then this one is I'll go over this later. But so the function to check the main CPU usage, what this does is that you have parameters for the CPU threshold, and then again the log file that we want to output to. So the CPU, this is strongly typed variable that we learned in class as the parameters. And then here, when we want to get every CPU usage per process, we'd use the get process commandlet, and this is a pipeline. So it's pipelining the it's like combining two commandlets together. So what it will do is it'll get the processes, and then it will along with where the it won't get the processes where they won't get system processes process that are idle, or Windows Defender processes, because these processes are responsible for like critical system functions. So if you were to delete them, that would cause it could cause the whole Windows to just like stop working, which we don't want, because we're just checking for CPU usage. We're not really like doing anything more than that. And then to get the total CPU, we use this commandlet, which will get this commandlet, which we specify that it's the CPU is the Windows 32 processor, and then the object property, because this is kind of like an object, and then here is the property. So then using the dot operator, so I load the percentage, and then I pass it to the CPU total variable that we declare, and then it will write the total CPU into the log. And then for our conditional logic, which is our if statement, if this total CPU is greater than the CPU threshold that we define. So like for example 80%, I think, yeah, 80%. Then it will it'll write the high CPU usage detected to the log file, and then it will use the for loop, which is our iterative logic. So for loop, which will, it's kind of similar to Python, where it'll check in the CPU process's object. It will check for each value. It will iterate through each value. Basically, once it goes to the first process, then it goes to the second process. All the processes that are stored, the list of all processes which are in here. And then if the process for that CPU, the percentage of if it's a high, like greater than 80% CPU process, if it's greater than the threshold that we define, like the limit, then it'll stop the process, and then it'll kill the CPU process and outputs a log file, the name, the ID, the amount of CPU that it was taking up, percentage of the CPU it was taking up, and then right here outputs a log file. And then we have exception handling here, so try catch block, kind of like Java. So we have a lot of exceptions in PowerShell as well. For example, like access denied. So we want to catch those exceptions, and then like obviously we know how try catch block works. And then else, if everything's fine, if there's low CPU usage or normal, then it will amplify CPU usage normal. And then for the memory usage, kind of a similar process, except we could get PowerShell to run an executable for a program that can clear your memory, like any overly high memory usage. So then we use another commandlet to get the memory and the total memory, and then we divide it by 1 megabit to get the total visible memory size. The free memory, we get how much memory is free, and then to get it, the amount of memory that's used in percent, we use the math.round, and then output to 2 decimal places. And then whatever this percentage is, we output to a log file. And then if the amount of used memory is greater than the threshold, so if it's 90% memory is used, high memory usage detected, and then it will run the executable for that tool that can clear the memory, the clear standby memory, and then it will start it can start the process with the arguments that we would run it with. So I think E would be to just clear the memory caches, and then output to the log, the remediation step, and then or else if everything's fine, then it was output to log file the normal memory usage. And then for the disk space, we'll use a get PS drive commandlet with we just basically want to get the C drive with the flag PS provider, and what it does is it gets the available space on the C drive. Now here we want to run our conditional logic, so if the drive exists, as long as the drive exists, this whole thing will, if that drive doesn't exist, then it'll be like it will skip the if block and it'll just go to else. And then here it will log the current disk space and the amount of free space that there is. And then it will run the switch statement based on the different disk space levels. So if it's less than the disk space threshold, it will output a lot. There's low disk space, and then here in this again exception handling for try catch block. What this would do is to help with the high disk usage. We'd have to look for one remediation we could do is just clear the temporary files. So what this would do is look for the temporary files directory, which is the Windows where Windows stores it, and then use get child item commandlet as the path where it's stored, and then we can use a for each loop to iterate through all the files, and then what we'll do is it will delete that file, or again exception handling if it can't delete the file. The reason being is because some files you just can't delete. And then that's it for the functions for each checking the disk space or the memory or the CPU. And then here, to perform our system health check, we want the amount of threshold we want. It could be changed to 90, or if the disk space is 5 gigabytes left. And then we want to specify the path or where we want to output the log file. So I just put it in documents. It could be changed anywhere else. So I write to the log running system health check, and then it would sequentially check CPU, memory, and disk space. It would just run the function that we declared earlier, check disk space with the parameters that we specified here. And then the CPU threshold would pass that value, so 80% here, or then the log file path here, and then these are basically the function arguments that are being passed to this function. And then we write to the log once this all been executed, system health check completed. And then since we have to run it every 5 minutes for testing, we use an infinite while loop, just like any other programming language or scripting language, and then every 5 minutes we write the log performing the system health check, and then where we want it to it'll be where it's going to be saved, the log file, and then we run this function for performing the system health check. We call that function. And then we write to the terminal that the check has been complete as well, because you want to know. You don't have to just look at the log file. You can just look at the output as well, that it's complete. Yeah, and then that's the script. Now to see the script in action, I'm just gonna run the stress tool quickly. And then not too much memory, because it's only 4 gigabytes that I gave it. And then this is gonna keep pouring out memory into the VM, and then just run the script. And then I'll clear the memory. I'll run this tool to clear the memory. And then complete, and then I'll I'll save the outputs log file. So, and then to run the CPU stress tool, let's see if we can run this again. Okay, this time it killed the high CPU process, which was the stress tool. There's a lot of stress tools that can be used. So here's a log file, and then performing system health check, a CPU check, and then high CPU usage detected, trying to kill the high CPU usage processes. So while it's attempting to kill and then high memory found, and then it'll run the tool that is used to clear the memory. That execute a file that is specified, and then once it's successful, memory cache is cleared successfully, and that's going to check the disk. And then the freeze only 3.73 gigabytes left. There's a low disk space detected, and that's going to try to clear temporary files. Now these files can't be deleted because I think they're VMware specific temporary files. And then system health check completed, and then it'll check again. And then the high CPU usage was detected, and then it'll kill the process, which was the stress tool that I used. So that was the high CPU process, and then yeah, I terminated it. And then memory usage is normal.